First, I wanted to introduce myself briefly. I have a varied background. I started in neuroscience. I did environmental advocacy, working to save whales in Mexico and other projects, and then became a lawyer in 2007. On my way to becoming a lawyer, realized how inefficient law is and how much work is still being done on paper and fax machines, and so decided to turn my focus to making legal work somewhat more efficient. You can see some of my thinking about the law, early thinking about legal technology on the blog that I posted at the bottom right, blog.linklegislation.com, and the open source repository that I'm working on with Wei and some other people through Demand Progress in the GitHub repository in the bottom left. So I have two goals today, and I hope by keeping them small, I can achieve them. First, I want to talk about how we're using search in legal applications. Would love to get your comments or questions, thoughts about it. Legal technology tends to be a little different from what you're used to in sort of standard data applications, because the data we work with is words and structured documents. So you'll also see that we start with generally XML documents, basically books, legal treatises, bills, things that have a hierarchical structure. And in doing that, we have to deal with the search capabilities and basically break it up somewhat differently. And number two is really my most important goal, which is hopefully I'll interest you in what we're doing and get you to help us do it better, either through ideas, work on the open source, or joining us at Xcential. I'll go through a brief history of what legal search is, or at least what legal search is to me. Some of the unique challenges that are brought by working in the legal space, a couple of the particular projects that we're working on, and then some ideas about where search in the legal space can go in the future using some of the technologies that Elasticsearch brings. I'm hoping to keep it to about 20 minutes. So if you have an appointment in like 10, well, I may go over, but I'm hoping to keep it somewhat short and then open to your questions and ideas. Any thoughts or questions or anything so far? So just a brief history of what it means to search in the legal space. As you can imagine, lawyers have been working with paper and parchment and stone tablets for a long time. Lawyers really like the idea of organizing information, and we've done it from the very beginning, say the 10 Commandments, the Bill of Rights. We really like lists. So our idea of search has often involved creating a list of legal information that's being produced, so that we were able to do search or a form of search well before there was any computerized indexing. Well, we have indexes of statutes in the United States, and that's what you see on the left here. We have indexes of named acts, so alphabetized lists of the names of laws, and then more specific organization of acts, like acts that somebody went through and found were held unconstitutional by the court, and so we have a big list of them, so you can look them up in a book. So moving from that to electronic search is somewhat of a challenge, because there's already a structure in place and lawyers have a way of thinking about it. But there are definitely efficiencies, because on the far right you see on page 1 we're up to 4 acts that were made held unconstitutional by the Supreme Court. You can imagine there are a whole lot more, and flipping through them isn't the most efficient way of finding the one you want. Back in the 1800s, there was this idea of updating your indices. And the way they did that is you have a book. The book makes references to, or the book shows cases that courts have decided, and later cases refer to the earlier cases. And so a guy called Shepard, his last name was Shepard, would make these sticky notes that you could put in your book every time there was a reference to a case in the book that you have. And so every lawyer would get their new stickies, would open up their book to the page where the reference is, and stick the stickies in. And so this was their idea of an incremental index. And law, as I mentioned before, brings some unique challenges that you don't usually see in, say, searching logs or searching data. I'll point out a few of these. One is that lawyers hate relevancy, meaning we're all, as consumers, we're trained to just put some words into Google, get the top 10 list, and more or less that's the answer we wanted. Lawyers don't want more or less the answer. They want the exact answer. If they're looking for a document, they know exactly which document they want, and they want that document to show up in the list. They may not care if it's the top in the list because they're paid to look through the entire list, right? So sort order, for most lawyers, they're not trained to think, give me the top ones and the top three. I just want to make sure the one I'm looking, I don't lose anything because I may get fired or the court may yell at me. Right? And that changes a little bit of how we have to talk about search to lawyers when we try to introduce an Elasticsearch type solution. Being fast is nice to have. Making sure that you don't miss anything is essential. Similar to that, they hate stop words. So, every word in a legal sentence is important. And if you're looking for a phrase that says, it's illegal to do this and that, that's important to know as opposed to say this or that. And then again related is lawyers like to do their searches with Booleans and with all of the operators that they know. And so weaning them off of that and letting them feel comfortable that the search that you're doing still returns the results that they want is part of our job as sort of legal technologists. Any thoughts or questions so far? So where are we working? Where have we worked? I got started with Elasticsearch in our work for the Office of the House Parliamentarian. Their basic work is to collect what is the precedent, what's the rule that is decided for Congress on any given day. I show an example on the right, but there are hundreds of these, actually thousands of these precedents that have been collected since the beginning of Congress. Like, what happens when a speaker speaks out of turn? What happens when one congressperson calls the other congressperson a bad word? What counts as a bad word when a congressperson, if you say you're a silly face, does that count, or does it have to be something much more, much stronger in order to count as an insult, right? So all of these originally were collected on actual index cards. The parliamentarian of the House, when they wanted to list out a precedent, say someone called someone a bad word and they wanted to say that bad word's not allowed, they'd flip through their index cards and say, okay, index card number 1250 from 1879 has speaker this person calling congressperson that a bad word, and the parliamentarian said that's not allowed. So search was flipping through the index cards, and the parliamentarian knew all of the index cards by heart and could find the card necessary at the time. We were asked by the parliamentarian actually, before us, that in those index cards were put into a SQL database, and the parliamentarian got to do a SQL search on that with an exact match. They were pretty happy with that for about 20 years. And then they came to us and said, can we do this faster? And we said, yeah, let's put in an Elasticsearch search. And we increased their speed by more than tenfold. It took them a while to feel comfortable with the results, to know that all the results that they want are there. But now it's really transformed the way that they look through their index cards. And one more point that I'd want to make is that we're not talking about a ton of data by most people's standards on this call. All of the cards over the 200-year period fits in about a gigabyte. And that's typical of the work that we do in legal search. It's all text. We're not doing images. We're not doing video. So as much work as Congress does, and it's been less and less recently, you're not searching through a huge volume of data, which goes back to the importance of finding the exact one you wanted, because it's not like you're finding one document in 100 million. You're finding the document in, say, 10,000, and it's a specific document they want. Another project that we're working on, this time open source, and through a different company. The Demand Progress is in a nonprofit organization that's funding this work, and this is the work that Wei is helping us on, is to find a bill that's like another bill. And I call this plagiarism software for bills. Why? Because, okay, you're a new congressperson, you come in, you want to make a name for yourself. And so, but really you don't know what you're doing. So what's the easiest way to offer a new bill? You look at the bills that were offered last year by someone else. You copy the parts you want, you put your name on it, and now I have the Ari Hershowitz bill for doing something pretty cool that my constituents will think is awesome. And there are many reasons why, as a researcher or as a person at the Library of Congress, for example, you'd want to know what bills, if you look at the new bills that are going to be introduced in January of 2021, whole new set of bills in the new Congress, about 90% of them are basically just repackaged bills from the previous Congresses with little bows on top. So if you want to write a summary of them, for example, or if you want to explain, you want to write a news article about them, it'd be nice to know that you're not dealing with a completely new bill. So in order to do this, we're using Elasticsearch again, different kind of search. It's not a text, a text search. We're using the more like this feature of Elasticsearch, and we're doing it in a very particular way because of the structure of bills. So if you put in the text of one section, we find all the other sections of all the other bills that have some similar text. And here I've put in a section that's from what's called the Mar-a-Lago Act. And it's a clever acronym, but basically it's an act that finds records of people that says that anyone who visits Mar-a-Lago to visit the president should go into the record book, just like they do when they visit the White House. And there have been, as you see here in our, a variety of different acts that try and do the same thing to collect visitor logs at somewhere other than the White House, right? And you wouldn't, the way I knew to look for this is the person who wrote this clause to go in, the lobbyist who wrote this said, hey, I know my clause has gone into a bunch of different bills. Can you find them? And that's how we did. But you don't always have that. And you want to go backwards and say, where else in proposed legislation is the language that we're looking for? And so we start with looking for one section in all the bills in Congress. And here we find 5, and you can imagine scrolling down, and there are a bunch of others where this one section is found. But what if I want to find all the bills that are related to a whole bill? So our current approach is you got all of the sections of the bill, you do the same search for each one of these, collect that information, and now you've got all the bills that have sections that are similar, and you have to make some score that combines all of those. What if one section is a very large section and it's almost identical to another bill, but all the other sections are different? Do we score that highly? Do we score it low? And that's the problem we're working on right now, is how do you both figure out, we've got a section that matched nicely, but also give some more weight to the whole bill is similar to the whole other bill. Does that all make sense? One last place we're working, states also make laws. In fact, other countries make laws. And so what we're trying to look for is a way to build a more generic search engine that works. As I said, it's different from, say, a Google search, because there's very particular kinds of search that lawyers want to do, but that works across different jurisdictions. We need to bring in the law in structured data in XML, link to the original sources. And here you see a demo on the right where we link to the page number in the book of the Oregon laws. And then make a user interface. And what you see on the right is my attempt to make a user interface. I'm sure there are people out there who can help us make them better and nicer. But there's a common problem set that we're seeing through from state to state, from country to country, that I think we can help solve with something like Elasticsearch on the back end. And that's basically where we're at. And as you see, we have a bunch of ideas. We have a bunch of places we're working, but we definitely would love to work with experts in the fields to advance the work that we're doing. And this last point is my main point, which is I hope some of you or some people working with Elasticsearch are willing to stop working on searching through logs and work with us on legislative text. That's what I've got. So I'd open it up to questions, suggestions, thoughts, complaints.
I see a question from Joel, and I also see, Joel, that you're unmuted if you want to go ahead and ask your question yourself.
Yeah, I was wondering about the input. You said that the documents are in XML format. So do you import XML into Elasticsearch? Is that the primary mode of bringing the content in?
Yeah, so we and a number of other entities and organizations have been working on standardizing XML schema for legislation, because and legislation in particular works really well with the structure of XML. So the United States Code has been translated into XML. Bills are in XML. So a lot of our legislative work assumes XML. The work we did, and I'll talk about that in a second, the work we did in the parliamentarian's office actually was not structured in the same way, because their notes go back much further than XML, and they're basically blobs in the SQL database. So we built a Logstash importer, and at the time there wasn't a standard one. So I think we used an open source JDBC translator to pull in the individual records from SQL. Sometimes we have to do that. Original data we're working with in other places in states comes from IBM mainframes. But what we're trying to do is translate that to XML first, and then build XML ingesting systems. And that's, your question is actually in a perfect place for us. We don't have yet a standardized way of bringing in the XML. So I've built a few Python scripts myself, but it'd be great if we had a more robust way of saying, here's XML data, this is how we translate it into search.
Okay, yeah, that's interesting, because I was thinking even if the various laws and documents that you're bringing in are in XML, of course, the schema has to be the same. Otherwise, it's hard to compare apples to apples and search for things, with all these different schemas, unless you bring them in and just create everything as one big field of text that you search over. But I assume, based on what you said earlier about different sections, you're not doing that.
No, and what we want to do is preserve the information that we got in the XML. So there's a schema called US legislative markup that it has been adopted by the government publishing office, and that's the primary schema we're working with. We, in general, laws follow the same pattern. So at the core piece of most legal documents is a section. And even if it's not called a section in the XML, it's got, you know, a related name. When we ingest it, we want to be able to translate, say, from section to the unit that we're ingesting. The other thing that's often really useful and important is the header, right? So every unit often has a title, and we call those headers. They may be named differently in different schema, but again, if we can pull in the header information and the text of the serialized text of a section, that usually gets us like 90% of the way there.
Okay, I'm sorry, could you mention again the name of that XML schema?
United States Legislative Markup, and let me do a quick search for it. It's USLM for short, and I'll put it in the chat.
Okay, great, thank you.
And we haven't even scratched the surface of the cool things that can be done once you have the structure, because what we'd love to do is you can search on any of the fields. You know, you put in the fields of the XML you care about, index it that way, and then the user will want to say, let me search for a section that has these words. Let me instead search for you know, a division that has these words in the title.
Sure, yeah, and one thing in my past experience where trying to normalize across a diverse set of document schemas that I found was, if you build a core schema and then there are certain fields that only exist in certain documents, you can search on those and still get hits on those documents, so you don't have to normalize every single field, which I found helpful.
That would be great. And that often happens. That's exactly what you know, our general rule working with legislatures, they get to do whatever they want. So you make a schema and you say, oh yes, it must include X. And the congressman writes it a certain way and they're like, I don't want X in my bill.
Right, yeah.
Other questions or thoughts? What's your background, Joel?
I worked on Watson at IBM, and it was for medical literature, and so my job was to normalize large data sets of medical literature into a common schema and create a search index out of that. So I had a lot of fun writing data normalizers and things where I actually created a common schema and then used some of these extension freedoms that Elastic allows to have rogue fields that would pop up in documents that I maybe didn't want to put into the core schema, but I would still be able to keep them and search them. So it was basically medical literature integration.
Yeah, and it's very, you know, lawyers and doctors have a lot of the same quirks. We read a lot of the same literature. And so it can be very similar, and we both still are using fax machines.
Yeah. No, that's why I found this very interesting, because I actually did think about that, and I went out and I looked at some of the laws on the web, and I thought, oh, I wonder what would it be to normalize those. And then I saw this seminar, and I thought, wow, this sounds interesting.
I'm so glad. Yeah. No, it sounds like a lot of the experience you have would be very relevant. Like you're ahead of where we have been in terms of translating the XML. So, do we have any thoughts? I see Howard and Raul, Antonio, Barbara. Okay, super.
I'll ask another one if I can.
Sure, as many.
The volumes that you deal with, how are there in terms of laws or documents, XML files, if you will, that you're bringing in? Are they hundreds, thousands, millions? How are you needing to scale this up? And I assume there are maybe different time frame limits that you abide by for certain searches, or just kind of a scope of things,
Yeah.
you know, that you work against?
So, right. So our typical data set is never millions. If it's massive, it's hundreds of thousands. It's usually tens of thousands. So just to give you a sense of scale, we're working with the bills of the United States Congress.
Okay.
US Congress, for all Congress people, all stages of all bills, which does not mean the ones that pass. It's just the ones that they put forward to maybe consider. All stages of all bills for a given Congress is about 20 to 30,000 per Congress.
Okay. And the size of each document is some megabytes, I assume?
Absolute biggest bill in the history of bills is 10 to 12 megabytes. Now, as a lawyer, it's a pain in the butt because it could be 1,400 pages, right?
Sure, yeah.
But it's still 10 megabytes maximum.
Okay.
As an XML file. It gets to be more if you make it into PDF, but that's not what we're generally working with. So our biggest data sets tend to be on the order of 8 gigabytes, maybe 10. If we do if we do versioning, it can get bigger because you have time points, unless you do smart versioning, in which case, so one of our collections is the current law data set, which is all of the current laws, and when a new law comes through, it either gets added or it amends an existing one. We're versioning that, and because we're versioning it, we're adding new stuff on top of the existing stuff, and we're not duplicating. It's less than 5 gigabytes.
Okay.
Our user base also, hopefully we're going to expand, but our typical user base inside of, say, a legislature is 10 or 15 people. So scale there is also not that critical. What is critical is they are very, 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 very picky. And as I said, if they do a search where they know what the answer is and our search doesn't get them the answer, sometimes because, say, when we serialized the XML, the two words got merged together, or maybe our stemming was not set up right, and so it didn't pick up, refer and referring.
Yep. Mm-hmm.
They don't trust the system anymore, and they pull out their books.
And I apologize if you mentioned this earlier, but in the course of doing these searches, have you built up a sort of dictionary or set of synonyms or definitions? How are you looking for similar terms? I apologize if I missed that.
I see. Okay, so our current approach is very simplistic, I guess. So there are a lot of, if there's any, large management consulting firms on the call, I apologize. But the approach of a lot of the large management consulting firms is they want to do AI or machine learning or something complicated. Lawyers care about words, just like exact words. And one word is not really the same as another for a lawyer. So when we do similarity searches, we look for, we're using the more like this search in Lucene, which is basically, words in a row that are the same, or words in a row that are matching. That's, so far we haven't had to go beyond that, and we're trying variations of that, because the more like this has a few parameters you can tweak. Mm-hmm. But similarity, for the most part, for lawyers is really word similarity, with allowing some variation in, say, what spaces there are, what words come in between. Synonyms don't, so far in my experience, don't do much for us.
Okay.
Does that make sense?
Yes, that's interesting.
And again, lots of people want to put in ontologies, and there's a huge academic literature on ontologies for law. but actual practitioners just don't use it.
Okay, thank you.
Raul, I may have misread, but it seemed like you toggled something and had a question. Okay, so I'm going to read it. Thank you, Raul. For your use case, what sort of challenges did you run into while configuring your text analyzers or tokenization stemming? Did you have to write a custom analyzer, or did you use pre-built analyzers that Elasticsearch ships with? And how do you track the performance of your text stemming and tokenization, relevancy, search results, meeting users' expectation? That is super question. So nothing out of the box works for our users, and that's part of why I want to extend the community of people who work with us. Number one, we had to use we built our own text analyzer. I did it myself. It may not be perfect or ideal, but there were certain things that our users clearly did not like in the first version, which used the default. One I mentioned, which is stop words. We had to get rid of stop words. We used the English stemming. We tweaked, I think, some of the ways that we have like word triplets and others broken up. And the truth is, beyond some of the things that the users told us directly, like the stop words, we used trial and error in the search, tried to get the sort of the biggest result set, or the most complete result set when someone does a query. Because as I said, our users would rather a result set be over-inclusive than under. And we'd love to have a system to test our tokenization or our analyzers. Our system was, I would build the prototype, our user tried it, they complained, I kept fixing it until they stopped complaining. But if you have experience, Raul, or anyone else, on how to do that iteration more I don't know, in a more organized fashion, we're open to it. For the bill Similarity, again, we're just in the beginning stages. For our work with the parliamentarian and the tokenizer, we built it a number of years ago, and we're updating it currently. But and I'm glad to share the analyzer that we ended up building. Raul, does that answer your question?
He says yes.
Super. Anyone else, or anyone want to share even like their background and what drew you in to this?
I never want to cut somebody off prematurely. So if you
thank you all so much. I'd love, Faith, I don't know how this works. Oh, yeah, sorry. I don't know how contacting folks works, but I would love to sort of get a list of who participated and be able to reach out.
Yeah, absolutely. I can share out your contact information. We don't have the reverse option available, but yeah, I can share out your contact information with folks in my follow-up to make sure that those who want to be connected can.
Okay, I would
reach out to you.
I'd very much encourage you guys to write to me and follow up, even if it's just to say hi and we keep connected.